Welcome to In the Know with Kat Bobineau. Today, my extra special guest is Dr. Mook, or AKA Dr. Tamuka, and he is the STEAMulator, also a protein engineer. Welcome to the show.
Thank you for having me, Kat. I'm so happy to be here on your show.
Oh, absolutely, absolutely. So, first things first, what is a protein engineer?
Okay, I love talking about proteins. Well, we can break it down into two things. So, first of all, proteins are the machines of our body. They do the work in biology, not just in human beings, but in animals and plants and viruses and bacteria. These are the workhorses of the molecular universe. And so, if you think about any biological function within the world, proteins are mediating that. So protein engineers try to make the process more efficient. We try to make sure these proteins are basically well maintained. We're basically the mechanics of the protein world. And then a few of us also try to make brand new proteins from scratch, proteins that have never existed before to tackle new problems that are existing now. Yeah.
Oh, that is amazing. So what I'm hearing is we kind of know about DNA, right? That is the architect of life, but proteins are what make the DNA, right? And so
Exactly.
we need to know what proteins are doing. And you're saying we're creating new ones?
Yes, yes. And Kat, you really connected several things right there. I mean, the central dogma is what we are all taught in biology and maybe in
Mhm.
biochemistry, which is that DNA is really the manual of the universe, right? This is what allows our cells to read and write, allows our cells to know how to make more cells, how to feed themselves, how to function. And then there is mRNA, which basically is a transcript from DNA. So it
Mhm.
basically is the temporary machinery that now then makes proteins, the
Mhm.
actual machines that do the work. And yes, there's several proteins in the universe. You saliva in your mouth,
Yeah.
protein, okay? Antibodies that fight against diseases, protein. Your hair is mostly made out of protein. The reason why meat or your blood is red is because of a protein, hemoglobin and myoglobin. So proteins are universal. And yes, these proteins, we have now known them, we have understood them, and we know that they are the molecular workhorses and machines. So now there's a group of protein engineers that are particularly from my PhD advisor's lab, Professor David Baker, that have been making new proteins to tackle some of the new sort of problems that we have in this world. Climate change, plastics, ever plastics, biofuel, remediation, just to name a couple few problems that we know and are tackling within our world. Well, protein engineers are at the front line trying to generate brand new proteins, brand new molecules from scratch to address these problems head on. And in fact, Professor David Baker actually won a Nobel Prize in
Oh,
chemistry in 2024, which was, as you can imagine, one of the proudest moments of my life.
oh my goodness. Okay, so many things coming up. First of all, I want to say thank you to everyone who's watching us live. I can see your comment. We can see your comments. So I see I am Tia 17 says good evening. So good evening to you. If you have
Hey, Tia.
if you guys have any questions or thoughts, drop them in the chat as we're doing the podcast live. So back to what you were saying, so many great things that you brought up, proteins being a marker of life. However, when people are thinking about it, we're thinking about ourselves, we're thinking about human beings, but you are bringing up proteins in the world, proteins that might help with climate change or help with mitigating plastic usage. I mean, who thought, well, you might not know who thought of this, but where did the concept of creating new proteins or engineering proteins, where did that concept come from?
No, that's a very great question. This actually started a long time ago, way before my advisor, way before the Baker Lab, way before de novo protein design was a thing. Humans have been evolving biological functions in
Mm-hmm.
making slight adjustments here and there. And in fact, there's a whole field called directed evolution, where we know the idea and concept of mutations. In the general world, people think of mutations as mistakes that happen along the way for some reason, right? Whether it's radiation onto your DNA that does DNA breakage, or
Mm-hmm.
maybe it's a viral based mutation, a virus comes into a cell and then, messes things up. But really, mutations are a feature and not a bug in life.
Mm-hmm.
Like the whole reason we are here as human beings is because of mutations.
Mm-hmm.
When the idea of our origin story, if you think of the theory of evolution, or even just think of
Mm-hmm.
the primordial soup, we started off likely of single cells, and mutations led us to evolve to become the human beings that we are today. And so that's a very much large, high level idea of it. The same thing is happening microscopically in a small level. Proteins have been evolving not only within different species, but also within, within the different domains of life. Bacterial
Mm-hmm.
proteins are evolving, algae, fungi proteins are evolving, plant proteins are evolving minutely. And scientists a long time ago discovered that they can actually do evolution in a test tube. And that's basically directed evolution, where you
Mm-hmm.
are loading mutations. And then once many mutations are made, you select or you screen based on the specific characteristics that you want. Pick the ones that you want, pick the ones that you don't want, analyze the proteins, compare the two of them, see what mutations are actually contributing to the good characteristics that you're looking for, and then combine them in a final variant that is actually your big one. This is how protein engineering was done for a really long time, way before some of these computational tools, these
Mm-hmm.
AI based tools, and machine learning started advancing. And so that's really where the roots of protein engineering come from compared to where it is today. And today we still use a lot of those tools, directed evolution, rational structure based design, in combination with some of these exciting deep learning and AI based tools.
Wow. Yeah. So when you are talking about evolution and mistakes or changes in the DNA, it makes me think of, Darwin and the Galapagos Islands and, what he's noticing with the different birds and the different beaks and how things are changing to adapt so that their offspring will be able to survive. Right.
Yeah.
And it's like survival of the fittest. Animals are going to mate with the stronger, the different, the mutation of the
Yeah.
animal world to make sure their offspring has a chance. So that has been that has happened in nature all since the dawn of time.
Yeah.
But
Yeah.
what protein engineers are doing is looking at that with in a microscopic level, right? And seeing what can be changed
Yeah.
to help out with humanity, so to speak. So
Like,
my thing, I would think of maybe like corn or maize,
mhm.
what is the mutation that needs to be done to make sure it's healthy and being able to grow and there
Yeah.
maybe grow in different areas that it's not normally grown. So that's a really cool concept to think about. So
And you've really grounded it in something real, which is
mhm,
agriculture, right?
mhm,
Because proteins exist in every domain of life, including
mhm,
plants. And you really brought up, Charles Darwin, who is the father of evolution. But
mhm,
really, Charles Darwin and a lot of scientists of that era were looking at these characteristics on a whole, these phenotypes, as we call them, right? And tying them back to this idea of a genotype, right? The DNA, and skipping this intermediary, the proteins, which are actually the ones that manifesting that characteristic, right? So in the same concept of maize or corn, as you brought it up, why is corn of today so sweet compared to
right.
original corn? And if you look at original corn pictures, they look very much different than the corn of
And they
today.
were very colorful, they're not just the
Very
yellow corn that we
colorful,
see. It was
purple,
very
yeah.
colorful. Yeah.
And
Yeah.
now it's all aesthetically yellow, and that's because of science in many
Mhm.
ways, and evolution, directed evolution, and even now in modern day time, we have GMOs, which are as a result of a lot of protein engineering, and some gene engineering still exists. A lot of breeding, crossbreeding, all of that, but really, I think protein engineering now advances a lot of those things faster than breeding sort of techniques, right? And so
Right.
that can apply in agriculture, but it can also apply in the therapeutic industry. So a lot of drugs are being made by protein engineers. One buzzword that has been dominating the zeitgeist in the last few years was actually made by a protein engineer, Ozempic. That is a protein made by a protein engineer. And I know a few who contributed it to that from my lab. And so
Okay. Now that's
protein
amazing.
engineers are saving the world in agriculture,
Okay.
in therapeutics, in every way, in every industry. Yeah.
I love it. I want to just break down one thing that you said, which was genotype versus phenotype. And so, for those who may not know, genotype is what's going on in the inside, and phenotype is how it's presented on the outside. So, you're having our protein engineers are looking at the genotype and looking at what's happening on the inside so that what's being shown on the outside is the
Yeah.
phenotype. So I just wanted to drop that little piece down. But so what got you into protein engineer? What made you decide like this was the career or this was the research you wanted to do?
Yeah, I have a very meandering story and journey. I think, as we all do, most people
Mhm.
think of a career path as just like a straight shot, to one line, but
Never,
most
it
of us
rarely is. I won't say never, but it rarely is.
rarely is, right? And
Mhm.
mine is no different. Definitely a meandering path, like a river, right? Yeah, I'm originally from Zimbabwe.
Mhm.
Born and raised in Zimbabwe. I came to America when I was 19 for undergrad. I did my bachelor's in biology and in the minor in chemistry at Claflin University. This was in a small town called Orangeburg in South Carolina, where Claflin University was the oldest HBCU in that
Mhm.
area. And so I was very fortunate to have a scholarship, merit-based scholarship to pursue my bachelor's there. And while there, as an international student from Zimbabwe, my dad is a factory worker by trade, and my mom is a secretary. So we were not coming from wealth or means. So the scholarship was really a safe haven, but that also meant
Mhm.
that during breaks, during summer break, winter break, and of course anything in between, I had to find campus housing.
Yeah.
I had to feed myself. I had to buy textbooks. I had to do, so many different things, which means I needed to work. And as an international student, you cannot work outside of campus. You can't go to McDonald's and apply, fill out
Mhm.
an application, as Nina Bonina Brown would say, right? You cannot do that.
Mhm.
But what we could do was research. And so that's why I was introduced at a very, very early time in my matriculation. In freshman year, with my thesis advisor, Dr. Nicholas Panasic, was doing some really exciting research with directed evolution of alpha beta type proteins, these proteins that are contribute to 10% of all enzymes in nature, enzymes being a class of these proteins that really do quite a lot of work. They're catalysts
Mhm.
in the world. And he was studying this family of enzymes using directed evolution methods. And I just completely fell in love with proteins. And from that point on, every summer I had an internship, two at Yale University, one at Purdue University, worked at
Mm.
BU, Boston University at my last one. And so I just really fell in love with the idea of proteins, these machines that people don't really know of and
Mhm.
don't really consider, but they are the ones doing almost all of the heavy lifting. And by the time I finished at Claflin University and graduated in 2012, I'd secured a post-baccalaureate internship, a longer internship, a year and a half long internship at a pharmaceutical company by the name of Novartis
Mm.
in Cambridge, Boston, Cambridge, Massachusetts. And during that time in this post-bac program that was designed to really help students apply to grad school, figure out if grad school is really for them, and if they go to grad school, what questions do you tackle? It was a really great program headed at that time by one of my mentors, Dr. Anastasia Award, as well as I had an actual oncology-based mentor, Dr. Michael Acker. And so during that time, I fell in love with the idea of, oh, I can not only can I go to school for this for free,
Mm-hmm.
get a PhD, they will actually pay me. I
Yes.
don't have to pay, they will pay me for working in the lab, answering questions that I'm already curious about anyway, with supplies and everything. I was like, oh, we're definitely doing this. And so I started applying to different schools, and that's where I discovered David Baker. I was like, oh my gosh, these proteins I have fallen in love with in nature, I can potentially have the opportunity to make my own, design my own using computation, and then experiment with those different proteins and characterize them, see if they match my designs. And so I really had to go to University of Washington. It was really a no-brainer right after that.
Mm-hmm.
And I was fortunate enough to land a rotation in his lab, very competitive. And also, again, fortunate enough to actually land a position in his lab for 5 years. And it was amazing, changed my life completely, a whole different trajectory that ended at the in 2019 with several papers. I was able to publish high impact papers on some of my work, but also patents. I was owning IP of molecules that I had made, generated in this pursuit of my PhD. And so at that point, yeah, industry and choosing different career paths for me was a smorgasbord, right? It was really
Mm-hmm.
choose your own adventure at that point, which is awesome as a person engineer.
Wow. That is amazing. So when you first went to Crichton, what was your major? Did you have a major or were you undecided?
No, when I went to Claflin, I thought I was going to be a medical doctor.
Oh, okay, okay.
When I first went there, and I started taking biochemistry classes, and that's where
Mhm.
this idea of, oh, I have to pay $50,000 minimum a year to become a doctor,
Yeah.
versus I get paid about
Mhm.
$50,000 a year to become a PhD doctor. I was like, oh, let's see.
We'll just go this way. Yeah.
Exactly, exactly. I was that first at it, and I fell in love with research. I was like, and so this is the fundamental part of your degree. You have to ask questions and answer questions through hands-on research and hands-on work. It just came natural to me. I was like, okay, this is the path I'm gonna go. Yeah.
And how did you find out about that school?
Claflin University. I
Mhm.
had a cousin who graduated
Okay.
there, and it was pretty popular in terms of being the oldest historically
Mhm.
black college in America. And coming from Zimbabwe, I thought, all you see in the news, in the headlines when you're in Zimbabwe about America and about is really just is awful stuff. Honestly, most of the time, it's really scary stuff. A lot of hurt, racism, is really amped up in the media. It's
I
pretty accurate in
mean,
some
you know
cases,
what
but
I'm
yeah,
saying? It's not wrong, you
yeah.
know.
But so it was very important for me and my parents that I would have a gradual acclimatization in
Mhm.
America. I had an uncle who also lived here, shout out Sekuru Boni, who really emphasized this idea of, oh, if you are at an HBCU, you will be among majority Black folks, which means you will slowly integrate into the system and who
Mhm.
might not be as exposed to,
The
racism and,
craziness.
some of the harsh realities of living in America and being Black in America as soon. You can concentrate on your studies for at least 4 years as you acclimatize, and then eventually,
Right.
once you get out into the world, which was really a great idea. It gave me such a solid foundation. I was able to do African American heritage studies, learn
Mhm.
about Black American culture. I pledged a fraternity, A
Okay.
Phi.
Okay.
Really fell in love with the Black American experience,
Mhm.
and really, had a solid foundation. HBCUs, that's one thing that they really specialize in. It's an intimate environment.
Mm-hmm.
It's about 30 students per class as opposed to PWIs when I went, later on UW. It's
200.
like 200 students per one professor. And so I had really
Mm-hmm.
good grounding during that time. So it was a good decision. Yeah.
That is amazing. So you came here thinking medical doctor, fell in love with the research aspect of it, fell in love with proteins as the research, got into this amazing lab at the University of Washington, which I know was probably competitive. And now you're holding patents. Is there any of the information that you either wrote about in your paper or you have patents for that you want to share?
Yeah, no, I don't mind.
Okay.
Yeah. So yeah, that's part of the joy of academic research is sharing and doing science communication is embedded in the reason why you are there. And so,
Hmm.
yeah, I'd love to talk about some of the work that I published. My first paper was actually in the journal called Science.
Hmm.
This was de novo design of a type of protein family, folder family, which is mixed alpha and beta sheet type proteins. These proteins, this family is really well known for being linked to becoming enzymes or
Hmm.
ligand binding, and so they do some of the heavy lifting within the world. And so the idea was if we could use our computational tools to make a brand new protein with this topology from scratch, a protein that looks nothing like anything that's ever existed in nature. And in fact, we searched, we looked, see if we can find a sequence and engineer a sequence that folds not only to have behavioral characteristics of a protein, but also to look just like this specific kind of protein family, all the while enhancing some of the other properties, like say we make it more stable, say
Yeah.
we impart some sort of function. Then it would not only validate the methods and the computational methods in the field, but it will also give us some insight and learning how proteins in nature typically turn to come to be, to fold, to become these machines and workhorses. And so that was my first paper, and then slowly I just started focusing in that lane. By the time I graduated, I had now focused less so on the alpha mechanisms and concentrated more on beta sheet type proteins. My specialty was de novo design for just all beta type proteins. Beta sheets typically are at the center of active sites for enzymes. They typically are the reason why we have antibodies fight against diseases, are mostly beta sheet type topologies. And so I was just really fascinated by that. And also, it was an outstanding challenge. The lab had gotten really good at designing helical based proteins, but not so much with beta sheet type proteins. So thought it was my way of making a mark. And so, in fact, some of the patents that you mentioned are of de novo designed all beta type proteins, so without any helix, just an all beta type protein. And then another one, which is a precursor for antibodies. It's called an IgG domain or immunoglobulin domain. And so I de novo designed together with my collaborators and really long time mentors. Shout out Dr. Marcos, Enrique Marcos, as well as David Baker, of course. We're able to design brand new scaffolds that never existed before in nature, that could be potentially used as new antibody like molecules. And so, yeah, that was the basis of my work during my time in not only the Baker Lab, but in what became the Institute for Protein Design, as I ended up staying there as a postdoc after being part of HHMI, or Howard Hughes Medical Institute.
Nice, nice. So we should be on the outlook for your own type of medicine like Ozempic that might be coming out for antibodies and for
Yes, yes, you
isn't this or
should.
something. Okay,
Yes, yes,
okay.
you should. And this is the kind of stuff that I like to teach using my platform at STEAMulater that you mentioned earlier on. And
Yes.
yes, yes, I think of protein design as really the culmination of STEAM, science, technology, engineering, arts, and mathematics. Obviously, the computational algorithms that underpin AI and all of these design tools are based in math, grounded in math
Mhm.
equations. There's an inherent, of course, use of technology, using computers, right, for these algorithms. And then this is engineering. Protein engineering is engineering in many disciplines and in many levels, not just, the actual biomedical engineering aspect of it, but then there's an electrical engineering component where
Mhm.
you kind of have to understand how these circuits work for your computer to actually function and be utilized. There is a computer science engineering element. Obviously, you're designing algorithms from scratch and automating your methods. And then embedded in all of this is art. Art is an artistic lens that through which you look at proteins, the beauty of these structures, these shapes, because in fact, the function of a protein is directly tied to its shape. And so, in order for us to understand how any of these things work, we really have to have an appreciation for that beautiful structure of the proteins. And obviously, this is all grounded in science. So, we get the entire STEAM in protein design. And the fact that, I was going through my career as a Black scientist and rarely ever seeing other Black scientists, maybe
Yes.
one of a few there, it really resonated to me that all these awesome tools and techniques that are winning Nobel Prizes, that are spinning out billion-dollar companies, are not within my community. A lot of people in my community do not have those skills, do not have those
Mhm.
resources, those tools, don't even know that that is a possibility or an outcome in the future. And so I started STEAMulater soon out, right out of grad school, with this idea of, can I explain what I do? Mixing
Yes,
molecules.
absolutely. I mean, I just want to say, I mean, you speaking to the choir here. I mean, this is
Yeah.
why I do what I do. This is why I have my program, my STEM Ed,
Nice.
because Black people, let's just say that, Black
Mhm.
people in science were often asked to go speak to a classroom, speak to this group, do this, because we're not seen in those fields.
Yeah.
And we need more exposure to people of color, especially Black people, doing different types of STEM or STEAM work
Yeah.
outside of sports and entertainment. And I don't know, please don't come after me for saying that, but yes,
It's true.
it's got to be more than sports and entertainment. And
Yeah.
so yeah, please tell us about STEAMulator and how you got started and what it is.
Yeah, I started with the simple concept. Can I explain what I do as a protein designer to my parents? I mentioned my parents. Dad, originally a factory worker, now retired. My mom
Mhm.
in HR, originally a secretary, climbed her career ladder to become, human resource manager.
Okay.
Um, yeah, which is so awesome. But
Yes.
both of them not in any science, And so even when I was in undergrad and I had, problems with, internships or these complex homework, I was supposed to
Mhm.
submit exams. It was really the advice I got from them was like, do your best, because
Just keep going. Just do something. Yeah.
best wishes. We all they could do was pray for me. You know
Mhm.
what I mean? And so I realized, oh, okay, not only can I find a way to explain what I'm doing to my parents and communicate to them in using, HR terms or even using machinery terms. And
Yeah.
when I saw that sort of resonating, I was like, oh, let me start a YouTube channel, connect with more of my community, more people, and see if I can talk to them, using pop culture references,
Yeah.
thinking of proteins as celebrities, which is something that I still do up to today. You'll see I make reels and TikToks where I highlight a protein and I, sort of talk about why it's famous, so why it's important
Mhm.
to know, and show you illustrations through animations. And then I started branching into more extreme sort of areas where I wanted to basically create my own field, my own discipline. I
Oh.
took hip hop and biochemistry and I meshed them together. There's so many educators who talk about using hip hop to teach teaching, to teach
Mhm.
architecture, to teach, different elements of writing and composition. And hip hop in itself is a very, popular field, but predominantly, uh, POC, I would say.
Yeah.
Black, but also
A
POC,
lot
I
of
would say.
us. Yes, yes, yes.
Yeah, a lot of us. So I was like, oh, perfect. It's a great medium to really talk to my community, talk to people who might not have had a great teacher and therefore was, in science and therefore were dissuaded to pursue science. And now talking to them in this fun and unique way talking about science in a different capacity. And so I started introducing, PDB molecules with PDB with Billboard hits. So go hit for hit. The Billboard
Mhm.
hit that is on the music charts that you're very familiar with. Now I link it with another hit in the biochemistry world, a
Mhm.
PDB protein that is also famous. And so, in fact, the first day I started with myoglobin, which is the very first protein that actually had a crystal structure ever. So it's the very first protein we knew what it looks like on a very microscopic level. And myoglobin is the reason why beef is red, for instance. It's the
Mhm.
reason why your meat is red. And I linked it with the very first entry of the best rapper, female rapper, well, but to me, rapper ever, Nicki Minaj. Her first entry in the Billboard knockout was basically about seeing red, and so it was a natural natural link between the two,
Yeah.
and it just took off from there. Hip hop biochemistry became a thing, not only on YouTube but on TikTok. Eventually I was doing podcasts like this, but
Yeah.
on Amazon's platform. So I collaborated with Amazon, actually getting paid to talk about it. And I started
Mm.
shows, eventually collaborated with PBS, which was really
What?
amazing. Great opportunity.
Where am I at? I need to get my life together. But yet, go ahead. I'm not jealous, but I am. But go ahead.
No, no, no. I mean, it's been an awesome ride. It's been amazing to meet also people like you. It's given me the opportunity to connect with fellow, scientists of all spectrums, which is really amazing. And then most recently, right now, in fact, as I'm talking to you, we're in the middle of the fifth season of my reality style STEM plus arts competition. So it's kind of think Survivor or Mr. Beast meets
Mm.
Bill Nye the Science Guy. It's been 3 years of this long running program called STEAMulater Games. And we are now in our fifth season where students basically learn a lot of these STEM based concepts about protein design while vying for a cash prize, a grand cash prize. So if you're listening to this right now, watching on Cat's podcast on the recap, or even live right
Mm.
now, you are open to sign up. Okay, we're playing for points this season, so you can jump in at any point in time. You might have a little disadvantage, you might be a little behind, but it's fine. If you compete in the challenges, you will not only stand to win, $100 cash prize for each challenge, but if you have the most points at the end of the season, which concludes this Sunday, April 26th, then you will win $1,000 cash on Cash App, sponsored by STEAMulater LLC. And this has been really, really fun this season, especially since we get the opportunity now to also talk to, podcasters like like that, and get the
Yes.
opportunity to come plug it on here, talk to
Mhm.
artists as well as other collaborators. We have artists that have come to our show through interviews, some that are dropping music every single day. There's an artist who was just on my show, who's dropping his album actually tonight.
Oh, wow. Okay, okay.
Tonight it drops midnight, April 24, 2026. His album is called Remedial by Remedy Rap, since it's a rap album, which is amazing and interesting.
It's like a science rap album?
It is not a
Okay.
science rap album, but he does have this concept of, stay in school, teach. One of the
Mm.
things that, I know right now, Nikki, is a controversial topic,
I
but,
don't wanna say anything, but,
yeah, I know.
if you
I
like it, I love it,
No,
whatever.
I know, but I don't mind diving into the controversy. If you don't mind, we could pull over real
I
quick.
mean that's up to you,
One thing is, Nikki, with where she is in her life right now, no other female rapper has ever reached that pinnacle. Like, she is the highest selling across tours, across music catalogs. She has the most number of billboards, number entries than any female artist, not just rapper, artist, period. Uh, the last crown was owned by Aretha, right? And then she's transitioned from rapper and performer to now mogul, like, perfumes, right? Brands. But also now the third level is she's actual label head. Like she owns her own label where she's signing artists. We have never seen this done by a woman in hip hop. Like hip hop started off being very, very misogynistic.
Oh
And
yes.
so women trying to get through that lane, it's been really hard. She's the first one we've seen make these strides and progress. And in doing that, she's also cultivated this really large community, large, diverse red hat community, right? Sorry, not red hat, big hat. It has some red hats in there, but big, big hat and big tent. One of the things that I thought would be interesting with her coming out as clearly loving Trump and MAGA, one silver line that I noticed was she had as a way to be able to speak to multiple type of people and connect across different camps in a way I would say Democrats and liberals are looking to do. So one thing that I would ask people is maybe find out what is that secret sauce, because she has Democrats as her diehard fans, her barbs, and she has MAGA as a diehard fans as barbs. She has religious people, non-religious people. She has people across all different camps. What is the secret sauce? And past that, I got to meet a lot of the community, the barbs within that fan base. Season 3 was all about Gag City. Whole 2024, I got to meet a lot of them. And in fact, this rapper we are talking about, Remedy Raps, is a barb. He's known barb. And a lot of the barbs have been inspired by the idea of writing your own lyrics, like Nikki does. It's one of the biggest markers that she says. Staying in school. Glad you find a silver line. That's funny, Tia. Staying in school, but also teaching, passing on the torch to the next generation. His album is called Remedial, and he's basically teaching people how to rap the way the legends were rapping, right? Not just Nicki, but Biggie, Tupac. These legends were rapping, which I think is very inspirational. And I mean,
I
you could
mean, I
tell I'm a
think
barb.
Tia's. Yeah, no, I can definitely tell you're a barb, and I'm on Tia's side of glad you found that silver lining. You know, I ain't no hater, so if that's who you like, great. And I like some of her songs. I have actually used some of her song, or at least one song, in presentations I've done. But yeah, she kind of lost me in the last few years. So I'm not like I said, I'm not gonna hate on her, but I'm also not gonna be like I'm a big fan at this moment. And people have their right to pick and choose where they want to be politically, but
Well,
this
what if
administration is not good for anybody.
what if
So
I had a way to bring you back around?
I don't think you do, but I mean, you're more than welcome to try. But
So
yeah.
most recently, what we were able to do with Stimulator Games Season 5 was convert lyrics to proteins, protein
Mhm.
molecules. This idea of teaching protein design to a wide audience has been really supercharged by the barbs. Okay, they've really taken it and run with it. And honestly,
Okay.
it's been great, mass adoption. And so I've been able to develop new tools, especially with all this vibe coding, develop a lot of resources for a lot of the communities to be able to utilize. And then with Nikki being somebody who has written really some powerful verses over the years, Monster, Super Bass, Moment for Life, a lot of these anthems that people hold near and dear to their hearts. One thing that she was doing was basically this challenge, this neurodivergence challenge she issued to the barbs, and people started writing lines that have been super crazy, that have they've unblocked memories within their lives. And we took those lines in season 5, these rap lyrics, these basically iconic bars that have been said, and we put them through a filter, the same filter that we use for proteins for drug therapy, proteins for agriculture, and we made brand new proteins from those.
Okay.
Proteins that were made in silico on the computer. And then I partnered with a company, a biotech company here in Boston called Ginkgo Bioworks, and those proteins were made in the lab. And so just yesterday, I got results back that at least half of those proteins, these, by the way, Nicki Minaj bars, okay, half of those are actual molecules, like
Okay.
protein molecules that have that have the same behavioral characteristics as the saliva in your mouth, have the same behavioral characteristics as lysozyme in your tears, enzyme in your tears, the same characteristics as antibodies that fight against diseases. So through Nikki and through her work, what we are charting now is not only a way to basically derive culture from culture. I like saying that, right?
Okay. Mhm. Get
Because
it? I
culture from
dig
the
it.
culture media.
Mhm.
Okay, yes,
Mhm. No, I
yes.
got it. I got it. But yes, go ahead.
But also novel scientific research and molecules coming from a community that is not well represented in science. So this is a direct argument against the detractors of DEI.
Mhm.
This field, hip hop biochemistry, would not exist without Black scientists like myself, without artists, unique artists, female artists within the hip hop field like Nicki Minaj. It is a field, and new molecules that never existed before would not exist without this. And so when people ask, why do we need DI? This is one reason right here. And Nikki's contributing to that.
Look,
Yeah.
we shouldn't even need DEI. I mean, you just need to bring the brightest people to the table, and some people
Yeah.
need to stop thinking they're the brightest and know everything when they clearly do not.
Yeah.
Um, and I appreciate the idea of her music, her lines, and people taking what she's doing and making it their own, and now creating culture from the culture and making proteins. Love all that.
Yeah.
Still don't have to like what she's about at this present time.
Of
You know,
course, of course. Yeah.
so she,
To each
what she doing, that's her life. But I gotta say, I'm not a big fan of how she's presenting herself as of late.
yeah.
Um,
I give
I
her the benefit of the doubt. There's a reason, I'm sure. We'll see. But anyway,
yeah, I mean,
who are some of your
whatever.
favorites?
She can do what she wants. I'm more of a Cardi B, Megan the Stallions fan. So
Yeah.
I love them a little bit more, a lot bit more than I'm feeling Nikki at this moment. Please don't come after me, Barb's. Y'all
No.
do what y'all want to do. I'm not hating. I'm not hating at all. I'm just saying for myself,
Yeah.
But at the end of the day, the main thing is that the information is being shared, the information is being done, and you're taking something that a lot of Black people are interested in, aka hip hop, and creating science around that, which
Mhm.
is basically something that we need. We need to, I'm trying to think of the best way to say it, but we need to be able to communicate with one another and push each other and push our next generation
Mhm.
into these fields by any means necessary at the moment. I think that we need to the idea of using this to and getting students to buy in, getting a cash prize, also learning about
Mhm.
science and biochem and proteins at the same time. All of that is very important. And Tia said, I love the concept of lyrics being proteins. Like, we are we gonna see that? Like, do we get to see on your show the proteins that are being made from these
Yeah.
lyrics? Okay, right.
Yes, yes. So I've been showing, reels of the journey because it's been a journey, from
Yeah.
and also these are specific concepts, right? So like for instance, the taking off those tweets and creating a data set, right? That is data analysis. That's introducing this concept of data capture methods, databases, what qualifies as data, what doesn't,
Hmm.
clean data, annotation of data, right? And then scripting tools that allow you to take from those data sets and verify which ones are lyrics, which ones are not. Now you are introducing the concept of algorithms that speed up the workflow. Instead of drag and drop and copy paste,
Hmm.
you're writing a Python script that allows you to interpret that. And then finally, some of the tools that do that conversion from lyrics to proteins. Because, I'm simplifying it a lot in talking here, but there is some work in between
Hmm.
there. Some AI based algorithms like protein MPNN, folding like AlphaFold and bolts, and introducing these ideas ideas and concepts that are so famous in certain parts of the world, but some people don't even know that they have access to them on their phone. And then finally, like pictures, this art portion, the artwork, the results, these pictures of proteins, brand new proteins that are very similar in characteristics to proteins that we know and love. So as I make these natural proteins as celebrities, I'm also
Mhm.
introducing this concept of you at home. My students are making proteins that they could present at conferences, and which we have done
Mm.
before. We went to Abercam's annual biomedical research conference for minoritized students, and some of my students presented their work there, which was so awesome to see. We are definitely writing all of this up, hopefully in a publication to come out, and of course, there'll be inherent IP based on any molecules that are actually make it to the whole pipeline. And so I'm
Right.
showing it in bits and pieces. And one of the things that I really love as well is that we're basically also creating a workflow,
Mhm.
a pipeline that anybody can repurpose. Because yes, we have been able to successfully demonstrate this with Nikki's lyrics, but those are in English.
Yeah.
What if we took, I'm from Zimbabwe, Shona phrases in Zimbabwe, proverbs, and converted those to proteins? What if
Mhm.
we took Spanish lyrics and converted them to proteins? There's so many things, so many directions we can go, and it really all kind of boils down to one main concept, which is the bedrock for STEAMulater.
Yeah.
Why I was the person to sort of bring it to the forefront, which is that you can take what you love the most, your hobby, the thing that you light up about, your passion,
Mhm.
whatever it is, if you like, Nicki Minaj in my case, or you like, lesser rappers in your case, you can take whatever it is you love and incentivize and push your academic learning. And so learning or academia doesn't have to be boring. It doesn't have to be slide after slide of mind-numbingly boring information.
Yeah.
You can spice it up with Beyonce flavor. You can. Why can't we answer the same question about what are the molecules that make up hair, and also ask who is Becky with the good hair? Why can't those two things
Right.
go
They,
in hand
they
in
can
hand?
coalesce. They can come together. You know.
Okay, why can't we be on PubMed publishing papers and also scrolling through the shade room?
Yeah. I mean,
Why
and
can't
that's
we do
the
that?
but that's the key. That's the key that I always talk about with like students and people is scientists and engineers and all of that are human, right?
Mhm.
They're just like you and me. They like Cardi B or lesser known rappers, and they're going to go on the shade room. They're gonna go, they love to go out to eat or they like to dress a certain way. You know what I'm
Yeah,
saying? So scientists are not removed from the rest of the world. They're just like everyone else. And so it's that stigma of the lab coat and eureka
mhm,
and I'm just a nerd just looking at this one thing. Yeah, I mean,
yeah,
proudly. I'm a proud nerd, but I also like to dance. I also like to eat. I also like to do all kinds of stuff.
yeah.
So, yeah, you know what I mean? Yes.
And the magic of science really happens at that interdisciplinary level, right? When we come out of our silos, like I'm just a biologist, I'm just a chemist, in this very
Mhm.
narrow, defined way that really media has sort of in Hollywood has orchestrated, right? It's not even
Yeah.
a genuine perspective. It's one that's manufactured in Hollywood. But when you step out of that box and start being interdisciplinary, mixing, art with engineering, mixing biology with dance,
Mhm.
mixing social media and non-traditional media, podcasting with science. When you start mixing that, that's where the true magic happens. Often I find people from multiple areas connecting really are able to become innovative and become real inventors in a new world. Oh, shout out to Tia.
I
Tia is
want
one of our
to share
students
that
in
one.
Student Life right now. And yeah, she is dropping the gems, Tia.
Yes, yes. For those who are listening, can't see, it says it would also bring people who normally wouldn't be interested or even know. It will bring new
Mhm.
people to love science. Absolutely. I mean,
Amen.
that is my ultimate goal with everything that I do is, especially now with my STEM ed, I bring STEM professionals into classrooms virtually once a month. And
Oh,
I'm trying to invite as many schools, as many programs who want to hear from real live STEM professionals joining the Zoom. You can talk to them, you can ask questions. They're gonna talk a little bit about what they do and then open it up for kids to ask questions, get involved, and and this is a way for our students to see the jobs that are currently there, and who knows what's coming next. But you may not have known about research until you went to college. I would rather in fifth grade that you can
Mhm.
do research. You know what I mean? So it's
That's
definitely a big thing.
amazing. That's really great. Sign me up. Okay. That
Okay, okay.
is
Thank
amazing.
you.
Congratulations to you. That is such a service within the community as well. It's so needed to be able to
It
connect
is. It is.
professionals to the younger generations, the next generation of scientists. Yeah.
Yeah, and they need to know, and they need to see people who look like them. They need to know what kind of careers are there, that you
Mhm.
could be interdisciplinary, that you can like,
Yeah.
you know, rappers who lose their mind, and as well as science. You can love all of it at the same time,
You can be both. No
You
reason
can
to
do it
be
all.
either or.
Absolutely. So, okay, anyways, so what's next? You graduated, you got a STEAMulater. Are you also working too? Or I mean, what all are you doing?
So yes, the answer, the quick answer is yes. As you know, from people with our background, we do not have the luxury to rest on our laurels and just pursue your passions willy nilly. You also have, I have family to take care of in Zimbabwe, my parents, of course, and siblings. I have responsibilities. Okay, I'm out here by myself, and so yeah, I do have a 9 to 5. I'm a protein engineer. I worked in biopharma, still do. I've worked in small tech and startups, up and down career, but still
Mhm.
ongoing as a protein engineer. I enjoy what I do. And when you enjoy what you do, they say you never work in a day in your life, but that's not true. You still get to work.
You still gotta
And
do
in terms of Stimulator, I really am stepping the gas now in a way that didn't exist before, because now we have wet lab based evidence that
Mm.
these ideas work. Yes, we're
Yeah.
exciting students like Tia, to, in a very interesting way. We're providing opportunities to multiple students to experience, what it's like being a scientist at a conference, what it's like being a scientist in a cross-functional team. But we are also creating a whole new field of research that is substantiated and backed up by real data, actual molecules in hand. So I look forward to basically, publishing all of this stuff, but also filing patents very soon, where my students and my co-hosts and co-authors will be on those patents. They will be co-authors on those. So again, giving IP into the community, allowing that to emulate further. Because yes, I had my idea to take my favorite rapper, the best one, and use her to to make these molecules. But that's an idea in my head.
Yeah.
What is that going to unlock in somebody else's head? They could decide to, I don't know. I have no idea where this could go. They could decide to really do some amazing things, fix the Flint water crisis from a
Oh
biochemistry
gosh,
standpoint.
and happening
Okay,
wherever. Yeah.
I had a student with a great idea. Amma Nicole wanted to make fashion more sustainable
Hmm.
by making a protein that would be a silk protein from
Mm.
scratch, instead of harvesting silk from silkworms and all that, non-sustainable, environmentally toxic workflow. Instead of that, generate synthetic proteins in the lab in a way that is safe and very convenient. And these silk proteins eventually, be on the fashion world stage on
I love
Vogue. I
that.
That was a novel idea. Ideas that are now coming out from people when they are given these resources and tools to go out into the world. And then, lastly, I will say, I have the
Wait,
theme
what?
song. Okay, yeah, the theme song for this season 5 for Stimulated Games is so I pick a song every season. I picked songs from season 1 and now season 5. The theme song is one that I made. I made the song using AI in
There
this
you go.
AI era. Okay, inspired by. Did you watch the interview with Zaina and Gail King?
No. Mm-mm,
Yeah,
mm-mm.
Gail King sat down, one of these AI artists, and was like, uh, you're creating this music. but where is it coming from? Why are you doing this when, when talented people, right, people with vocal cords should be the ones who are making the music? And she saw it as a tool that adds to the pantheon of tools that already exist to make music. And then Gail was like, well, but you can't sing. which is so true. Which is so true. But what is also happening is now people who like her, like me, who cannot sing, right, who cannot play the instrument to save their life, are able to participate in the origins of why music exists in humanity, which is to spread a message and connect on a deeper level with humans. We have been blocked out without access from that because of the lack of talent. Now, because of AI, we're able to communicate our message. And one example is my song for this season 5. It's called "Science Rules the World,"
Mhm.
and we also have an album, an EP coming out May 1st, where it's a song representing each of the STEAM elements: science, technology, engineering, arts, and mathematics. And it's a whole journey where my musical AI avatar walks you through these. And then eventually, since we've already answered the question, can you take lyrics and turn them to molecules? I will be taking molecules, turning them into songs,
Lyrics. Mm.
and find out, what does hemoglobin say? What does the saliva in your mouth want to say? What's the music that it wants to give into the world? And so I'm very excited about it. Look out for the STEAMulater EP by the title "Who Rules the World? STEAM."
Okay. All right. All right. So we got two questions, and I know we're coming towards the end. The first one was, how would I help students understand science in an English class? The middle school students are reading Hidden Figures. And you can feel free to jump in and answer the question as well. My first thought of that would be talking more or bringing more of what they were doing in Hidden Figures. So computer science, um, astronomy or math is the big one, math. And you can also tie math to music. I mean, all the notes and all the things that's happening in math is based off of music. But one of the things is just kind to, I think, let me rewind. For the most part, students feel like they don't always have a voice. And
Mhm.
so ask them, what science do they see in the book that they're reading, or asking them what comes up for them when they're reading this book and thinking about what the work that these women did, and then going from there. And you can always reach me. I'm super easy to find. I know I can find you a computer scientist or someone like that to talk to the class, or someone who works at NASA. One of my good friends, she's an astronaut at NASA, and she
Nice.
was actually her mentor slash friend was Katherine Johnson. So she was really good. She was really
Ah,
close with Katherine
that's
Johnson.
amazing.
So, but yeah, I always my big thing is letting students have a voice in what they want to do and study, and then going from there.
I love that. I love that. I would only add to that, that maybe even break down what science is. I think people think of science as a siloed discipline, when really science is a way of thinking. Like, it's a way
Hmm.
of following a protocol, right? Science is defined as coming up with a hypothesis or a theory, and then making experiments, designing experiments to test or disprove or prove that theory, correct or wrong, and then getting results based from your experiments, analyzing those results, or data now that we call it, right, that comes out,
Hmm.
and then making logical, data driven conclusions based on that. And that either support the hypothesis or allow you to reject the hypothesis for no. And that process of science, that is a way of thinking. That is what ties all scientists together. The
Hmm.
science that I do here, the why it's called a science, right, is because it's the same in England, it's the same in Italy, it's the same in
Hmm.
Zimbabwe, it's the same in Nigeria, it's the same in China. 1 plus 1 equals 2 everywhere. That is because we follow that reason based, that logic based, those, and we activate those critical thinking skills through hypothesis generation all the way through to conclusion. And I think that is something that it would be great to teach students at a very young age, particularly in
Yes.
this time that we're in, that not all theories are facts. Okay,
Yeah.
facts are facts, and facts come up after a whole process, scientific, rigorous process.
Right.
Yeah.
Right. I totally agree. And teaching them to think. Don't let AI do the thinking for you.
Yep.
Think it through. All right. Our last question right now would be, how can you mix what you do with sports?
Oh, shout out James Earl Rockefeller coming through with the question I love. Oh yeah. So now that we basically have proven that hip hop biochemistry is a thing, okay, like it's an actual thing, it's a discipline that we have invented that is gonna we'll see where it goes. Yeah, and if my philosophy is that you can use anything that you love, whatever it is, to learn and fuel your academic learning or to fuel your independent study, why can't we use sports to do the same thing, to do the same idea, right?
Mhm.
Why can't we take players, right, that are the celebrities of the sports world? Why can't we use those as analogies for teaching really complex theories within our world? Like sports is already kind of used for teaching physics, right? Like in
Mhm.
cricket, you learn trajectories, baseball, you learn velocity of the ball and all this kind of stuff. Why can't we extrapolate some other really popular sport terminology into science, like the statistics of a basketball game? Like that's math right there.
Mhm.
Okay. And many different areas. And so I think hip hop biochemistry is an example and a case study that can really open the doors for a lot of other mixtures, other interdisciplinary science. And one that focuses on sports, I think, is a really nice way to reach the youth and as well as people who are otherwise not interested in science but interested in sports, and introducing these new concepts and tools to them. So thank you for that question, James. Yeah.
Yeah. I mean, I would just add and take from what you said, which is the scientific method. I mean, that you see that in sports all day. If the football team, if one side is going to run this play, the hypothesis is it going to result in a touchdown, right?
That's right.
And so now you're going to run the whole play, which is doing the experiment. You're going to get your data. Either you're going to get sacked or
Yeah.
hit, or you're going to make a or you're going to make a touchdown. Boom,
Exactly.
there's your data, and then you get your conclusion. You did it
Yeah.
right, or it didn't work. So
I love that. That
it's
is
one of
great.
those things. Yeah. I mean,
Yeah.
you can use the scientific method for basically anything.
Anything at
It's a
all.
way of
Yeah.
life. All
Love
right,
that.
so are we actually over our hour? But before I let you go, I want to ask you two simple, or not simple, but two questions. One, where can we find all your information and look for you and learn more about you? And then two, what would you tell your 10-year-old self?
Ooh, ooh, that's a good one. That's a good one. Yeah, I will start with an easier one. Okay, you can find me on all things social, on all platforms at STEAMulater. That's STEAM as in STEM plus arts, STEAMU, and later.
Mhm,
And also on my website, yes, you just pulled it up. This is
mhm.
stimulator.com. And remember, there's no O in stimulator. Often people put an O where the E is. And so you can find me there. But I'm also on Facebook, Instagram, Twitch, Kick, Fanbase, everywhere where you consume your social media. I am there at Stimulator. And what I would say to a young Mook, a young Tamuka, which I'm also saying in my music right now, my AI avatar is actually a young boy who is meant to emulate me. His name is Mwana Steam. Mwana is a Zimbabwean term um, for child. So literally, child of steam is what's the translation, which for me has many meanings, many layers. One, it's definitely, the culmination, as I say, AI is the culmination of STEAM, science, technology, engineering,
Mhm.
arts, and mathematics, but also um, I strive to be the mentor that I didn't have when I was 10,
Mhm.
when I was young. And I now looking back at myself and saying, hey, stick the course. Number one, what's for you is for you. Number two, work ethic trumps any trial and tribulation in
Mhm.
life. Do the work. less shortcuts and more work. Long hours pay off ultimately. Doing your homework on time pays off ultimately.
Mhm.
And lastly, there is a world out there that you'll get to see one day, and that science can take you to that world if you, yeah, stick to it. Find good people, find good mentors along your journey, and connect with fellow scientists and fellow like minded folks. And one day you'll be on a podcast with exactly that kind of like-minded person by the name of Kat. And I just want to say, Kat, thank you so much for having me on your show today. This has
Of
been a really
course.
great conversation. A
Yes,
nice
I love
highlight to the
it.
end of
Thank
the week.
you.
Yeah.
Thank you. Thank you. And thank you to everyone who joined us live. Thank you for all the amazing comments and questions in the chat. Um, until next time, I'm going to shut it down because I need to eat dinner. It is
Yeah.
late and I'm hungry. So,
And like I always say at the ends of my shows, like, I won't see you later. I will steam you later.
and goodbye.